Hello, welcome to this part that is the plots of neuroblastoma data frame. We downloaded the neuroblastoma data frame in the last part. We did some processing on that data frame. So let's now start visualizing information contained in the data frame. So in the data folder in the drive, in the shared drive, we have the R2 GSE 62564 GSVA metadata.rds. This is the data frame or the R data set that we're going to be working with today. We go here to the course web page, and it's the data visualization. I can click on it again. There you go. First step here is to load libraries. I'm not gonna do this now. Let's see here. This part one, upload process data file. Remember that we downloaded the data set from the R2 database. Okay. In this case here, I have the R data set in a folder called results. So I already have RStudio open here. You can see here the console. Let me see if I can actually read. Let me see if I can run this one line here without problems. It's complaining that the results folder is not there. So what I'm gonna do is I'm going to download this file here in my desktop. I'm gonna download it in my desktop for now. I'm saving it there. Come back here. I'll go back to the line that I just ran. And I know that, so I put it in my desktop. So I'm gonna do the desktop. And then it should be there, the R2. There you go. So I can remove this. I can remove the results. Let's go to the end. So if I do, I can remove these letters, the RDS, and if I hit tab, it auto completes for me because this data is in my desktop. So I'm hitting enter and it's reading. So now we have the, if I do an ls, I see that my, so ls stands for list, and this command is listing the objects that are in the R environment. I can also, in RStudio, I can also click this environment tab, and we can see here the object R2 underscore GSC 62564 underscore GSVA underscore metadata, 498 observations of 25,000 variables. Okay, so this object is in my environment now. Let us see what the next steps are. So we just loaded the object, and I think in one of the in the previous notebook we did some processing with the metadata information. This object now that we are downloading should have all of the metadata information. So in neuroblastoma, the main risk classification systems classifies the patients using features such as age at diagnosis, the stage of the disease, the histology of the tumor, and the MYC-N amplification status. Prognosis is the association between features of the tumors and survival of the patients. MYC-N is a gene that encodes a transcription factor that is a very important gene in tumor prognosis. Let's take a look at the gene expression of MYC-N compared to the neuroblastoma risk group. So first, let's take a look at the MYC-N status at this variable and the MYC-N expression. In order to be able to visualize that, we need to understand what is the class of the MYC-N status variable. So if I just copy this line and paste it in the environment, remember, the reason why I'm able to get information about the MYC-N status, so the MYC-N status is a variable in the data frame, right? Just make sure you have the R2 data frame in the R environment, okay? So for example, if I remove the 3 letters of the word status here and I hit tab, it auto-completes for me. And the reason why it auto-completes is because the MYC-N underscore status variable is already present in the data frame. So now I'm asking R, what's the class of that one variable, the MYC-N underscore status, and I hit return or enter. It's telling me it's character, just as it did here. So the MYC-N status is actually, I'm going to say it's a clinical variable. Okay, it's a clinical variable. Now, the MYC-N gene expression is the gene MYC-N, the expression of that gene. And I can also check what the class of that variable is. And it's also telling me it's a character. But I need, both of them are of type character. But in order to plot, we have to make the MYC-N expression as numeric, okay? And the way that we do that in R, the way that we transform the MYC-N variable from character to numeric, we need to use this function as numeric, and that's going to make the MYC-N variable numeric. So if I copy this line now and paste it here, and let me copy this line now. So remember that before, I can actually, this line was the same one that I just copied. So I can go to the upward arrow and I can ask R again what the class of the MYC-N is now. And now it happens. It is numeric now because I just told R to make it become numeric with this as numeric function. So now we have the MYC-N variable numeric. There is some information here about age at diagnosis. I'm going to skip that for now. Let's go to part 2, because now that we have the MYC-N variable, the capital MYC-N variable as numeric, we can now plot MYC-N. I am seeing here that I put a note that this command, the way that it is, there's an error. Apparently this fixed the error, but let me try this for this third chunk here to see if this is going to generate a visualization for us. Apparently here I have to use the ggplot2 library, so I'll go ahead and copy that line. And then what this line seems to be doing is it's taking, I'm using the ggplot function, okay? And then I am taking the data frame, the R2 underscore GSC 62564 GSVA metadata data frame. And there is this other AES function, which stands for aesthetic. And in that function, it is telling me, this line is telling us to take the MYC-N underscore status as the x-axis. And you're going to see here what that means. I'm going to use the MYC-N status as the x-axis. And then the capital MYC-N as the y-axis, okay? the capital MUCAN as the y-axis, and then the fill argument, which has to do with the coloring of the groups. That's why you see the different colors here. It's also going to be the same as the x-axis. So let's go ahead and copy this line and put it here and see what happens. So we were able to generate this visualization. So again, in the x-axis, we have the MUCAN status, whether the patient has MUCAN amplification or not. And in the y-axis, we have the, if I remember correctly, this is the counts. And at some point, we are going to discuss what the counts means. But for now, let us understand that this is the MUCAN gene expression. So patients that have MUCAN amplification have higher MUCAN counts or MUCAN gene expression compared to patients that do not have MUCAN amplification. So MUCAN underscore non-amp means MUCAN non-amplified. So these patients do not have MUCAN amplification. And again, MUCAN amplification is one, you can understand it as a prognosis factor. If the person has MUCAN amplification, unfortunately, the person is going to have a much worse prognosis than the patient that do not have MUCAN amplification. All right, so let me actually close this. And let's come back here. What we can do now is we can take a look at the risk status, the high risk, and the MUCAN expression. So before we used the, sorry, not the MUCAN status, the MUCAN gene expression. Before we looked at the MUCAN expression and the MUCAN status, let's now take a look at the high risk group versus the MUCAN amplification. So here is the line of code. We will not have to upload the ggplot2 library again. We just did that in the previous in one of the previous commands. So we are going to again use the same data frame. We are going to use the same AES function, but now instead of having MUCAN status as the clinical variable, we're going to have the high risk variable as the x-axis. And again, in the y-axis, we're going to use the MUCAN counts, okay? We are going to continue using the MUCAN underscore status as the filling variable. And I'm going to comment this after we plot the high risk versus MUCAN counts. So I'm actually going to write down all of the commands. So ggplot is the command. And then I'm going to do the R2 underscore it R shows me what the data frame is. And then I'm going to use the AES function. And if I follow the auto completion that R provides us with, it opens and closes the parentheses. And we have to specify the X, the Y, and the fill arguments for the AES function. So X equals, it's going to be the high risk. The Y argument is going to be the MUCAN because it's the MUCAN gene expression. And then the fill argument is going to be the MUCAN, the MUCAN status. And then I need to tell the ggplot command which type of a plot do I want to have. In this case, it's going to be the box plot. And the way that we specify that is by using this geom underscore box plot, open parentheses, close parentheses. So that's what the line is going to look like. I really encourage you to type letter by letter so that you can get your brain used to typing this information. So I'll go ahead and hit enter. All right, I was able to generate another plot. This time it was the high risk as the clinical variable in the x-axis and the MIC-N counts as the y-axis. And again, the MIC-N here is the MIC-N gene expression. So we have two groups as the high-risk groups. We have the group that is yes, they have high-risk disease, and the group that is no, they do not have high-risk disease. Note that people with high risk have a high, first of all, they have MIC-N amplification, right? The people that do not have high risk do not have MIC-N amplification. And of course, the MIC-N gene expression is going to be much higher for the high risk group because they do have MIC-N amplification in this high risk group. Okay, let's do one thing. Let's now let's only use the high risk variable for the feeling argument. So the only thing that we're going to change now, instead of having MIC-N status here, let's have high risk status. Is that the only difference? Yes. So I'll hit enter. And now we just generated this plot where we're basically coloring the categories using the high risk variable instead of the MIC-N variable as we did here. So there you go. We were able to generate the visualization of one, the high risk, two clinical variables, the MIC-N status and the high risk status. And we see that basically the high risk patients, they have a high expression of the MIC-N gene, and also they have a high number of patients that are MIC-N amplified. All right, that's it for now. So we were able to generate some other visualization for the data set that we're working with.